Okay, so now we're going to start the subject or the topic of stoichiometry. And you've heard that word before, hopefully in an intro chem class. What is stoichiometry? Basically, it is calculations based on, and here's the important thing, a balanced chemical equation. So anytime you're doing stoichiometry, you must start off with a balanced chemical equation. You can't do any of the calculations until you first have a balanced chemical equation. In chapter 3, we're going to learn reaction stoichiometry, and then we're going to be dealing with limiting reactant stoichiometry. In chapter 4, we deal with solution stoichiometry. In chapter 5, we deal with gas stoichiometry. In chapter 6, we deal with thermochemical stoichiometry. And what do they all have in common? You have to start off with a balanced chemical equation, okay? So let's start off today with our first stoichiometry problem. Propane reacts with oxygen to produce carbon dioxide and water. Propane is C3H8 plus O2 will give you CO2 plus H2O. There's our equation. Is it balanced? No, it isn't. So we need to balance it before we can even begin to do anything with the problem. All right. So you have 3 carbons. Let's put a 3 here. That's our carbons are done. You have 8 hydrogens. We'll put a 4 here. Our hydrogens are done. 3 times 2 is 6 plus 4 is 10. We have 10 oxygens on this side. We'll put a 5 here. Okay, so now we have a balanced chemical equation. Let me just show you the whole thing here. Hopefully you can see everything fine. And let's see what the problem says. It says that, let me see here. How many grams of oxygen are required to burn 20.0 grams of propane, C3H8. The thing with stoichiometry is that you can get information, you can be given information about a reactant, and they could ask you about a product, or they could give you information about a product and ask you information about a reactant, or they could give you information, as in this case, about a reactant and ask you about another reactant, or they could give you information about a product and ask you about another product. So basically, in regular stoichiometry, regular reaction stoichiometry, there are 2 things. One thing you know, and then the other thing you want to find out, okay? And then you can ignore everybody else. So right now we're just focusing on the oxygen and the propane, and we're ignoring all of these guys. In this stoichiometry problem, they've started us off with mass of propane. Now, before we get into the calculations, let me tell you, you have to look at the coefficients of the balanced equation to be able to relate to one substance to the other. So you can read this equation and you can say 1 mole of propane molecules will react with 5 moles of oxygen molecules to produce 3 moles of carbon dioxide molecules and 4 moles of water molecules. Okay, so you're looking at those coefficients as molar quantities and you are relating one to the other. You could also look at it as 1 molecule of this reacts with 5 molecules of this to produce 3 molecules of this and 4 molecules of this. But when we're talking grams, we're going to have to think molar quantities because we're going to need molar mass to convert our grams to moles. Now, the thing that students make a mistake of is they say, oh, 20 grams of this, so we don't need to use the ratios at all. We'll just say, oh, I'm just going to take this 20 grams and just multiply it by 5, but because it looks like Oxygen is 5 times propane, so no problem. You can't do that because the way these are related is 1 mole of this is related to 5 moles of this. Not 1 gram is related to 5 grams, okay? So when you are given grams, the first thing you want to do is convert your grams to moles. So we're going to write 20.0 grams of propane, C3H8, and you're going to get the molar mass of propane. You add up the 3 carbons and the 8 hydrogens, and you get 1 mole of propane is 44.1 grams of propane, C3H8. Okay? Just quickly did it in my head here. All right. Grams of propane canceled. Now we have moles of propane. Now we can relate propane to oxygen. And we'll say, for every 1 mole of propane, you're going to need 5 moles of oxygen. Hopefully, so far, so good. Okay? Moles of propane have been canceled. Now that we have moles of oxygen, we can now get grams of oxygen. Now, you see oxygen is a diatomic molecule, so obviously this is 32 grams per mole. You say 1 mole of oxygen weighs 32.0 grams of oxygen, because 1 oxygen is 16 times 2. Again, you got your handy dandy periodic table always with you so you can add up your molar masses. All right, great. It's properly set up. Everything cancels. You end up with grams of oxygen. How many sig figs are we going to round it to? 3, because the number they've given you, the measured quantity is 3. So I have my calculator. Let's do the math together. We have 20 divided by 44.1 times 5 times 32, press equals, it's 72.6 grams of oxygen. Obviously, the calculator gives you a big, humongous number, 72.562358828. You cannot use all those sig figs. You only can do 3 sig figs. So it says 72.56 because the number to the right of the 5 is a 5 or higher. You round up, so you end up with 72.6. Okay, good. Let's do another one, all right? Sometimes they don't give you grams. Sometimes they give you moles, all right? So let's do something like this. Actually, this one will be an introduction to the limiting reactant problem. So the first example was a reaction stoichiometry, just a regular reaction stoichiometry. They give you one piece of information and you need to find another piece of information, and that's it. And everything else is in excess and you don't need to worry about anything else. With limiting reactant, you're always limited. They give you information, and this is important to recognize limiting reactant problems. How do you recognize a limiting reactant problems? They always give you information about 2 or more reactants. And then one of them is limiting and the other one is in excess. So let me show you this problem here. We'll do this and then we'll do another one as another example too. All right, so I'm going to just go ahead and copy this equation they have here. don't think I've ever done a problem with zirconium before. How interesting. Okay, so we need to balance this equation. You can see here that you've got 4 chlorines over here. You've got 2 over here. If you put a 2, that balances out the chlorines. And then you got the 2 magnesiums, put a 2 here. Okay, so now it's balanced. All right, good. So the question is, how many moles of zirconium metal, so how many moles of zirconium metal, this guy, can be produced from 0.20 moles of zirconium 4 chloride and 0.50 moles of magnesium. Now this is important. Remember how I told you guys, you can recognize a limiting reactant problem when they give you information about more than one reactant. So they've given us information about 2 reactants here. So this is what you do. You do 2 stoichiometry problems. You're going to relate the zirconium 4 chloride to zirconium and the magnesium to the zirconium. So let me show you what I'm talking about. Again, we don't need molar mass in this because all they want is moles. They've given us moles and they want to find moles. And so what we're going to do is we're going to use the molar ratio. All right. So we're going to go 0.20 moles of ZrCl4. And I want to get a molar ratio to get zirconium. So for every 1 mole of this, you get 1 mole of this. So that's what you write. 1 mole of ZrCl4, 1 mole of Zr. So this stoichiometry gives you 0.20 moles. Okay, that's the first one. Remember I said we're going to do 2 stoichiometry problems. Then we do the second one. 0.50 moles of magnesium. We're going to relate it to the zirconium. 2 moles of magnesium. Why did I say 2? Because you have a 2 in your coefficient here. 2 moles of magnesium will produce 1 mole of zirconium. You see that? So we do the math. 0.5 divided by 2 is 0.25 moles of Zr. Okay. Hopefully you can see this mess here. I know it looks messy. Sorry about that, guys. All right, so what did these 2 stoichiometry problems explain to us? Well, they showed us the maximum amount of zirconium you can get if you start off with this or if you start off with this. What you do in a limiting reactant problem is you always find the one that is least, the least one, that would be the answer. So how many moles of zirconium can be produced from this mixture? This guy, 0.20 moles of zirconium, because 0.25 moles is more. So what this is telling us is that this guy, ZrCl4, is the limiting reactant, and the magnesium is in excess. Okay? In the next video, we'll do a bigger problem with grams, and we will find out which substance is the limiting reactant, which substance is in excess, and how much of that excess substance is left over at the end of the limiting reactant problem. Okay? All right, good.